How many computers in this room? I don't know, many. We are surrounded by computers. And without software, computer doesn't do anything. So we need software. So, and then we have the long history of the software business for 40 years, 50 years. It's a long history of software business. So the commodity softwares are already developed. So even though we need software for everything, so we need software to, say, to transport, we need software to shopping, to do shopping, we need software to, say, electricity, airport, planes, everything, manufacturing. And then we are living in the software-driven society. And we need more and more software since everything is driven by software. And then since the commodity software is already developed, already there, so we need to create software more quickly. We already have tons of software. We need whole new software to do something which no one ever imagined, to create something new. That's the the front line of the software development, and we are living in the front line since this is San Francisco. And we don't know what is the right software, since no one ever imagined the software you are creating. You might have a vague image in your brain, but you don't know this is the right thing to do. So we need to explore. That's the only way to create great software. By the way, I have a question for you. How many times did you write hello world? 1, 2, at least once for every language you wrote. And the second question is, how many times did you write hello world without bugs? Probably every time, since hello world is pretty much easier, except in assembly. Then, how many times did you write in FizzBuzz? Many times? Or once? How about writing FizzBuzz without bugs? So it is quite easy to write small programs. It is quite easy to write small software, just because it's small. You can understand everything. Maybe 5 lines of code, maybe 100 lines of code is enough. But if your software grows 1,000 lines, or tens of thousands of lines, or even million lines of code, the Toyota Prius is kind of running computer with a software of millions of lines of software. It's kind of scary, isn't it? Software. We are software developers. We see a lot of bugs. We can imagine how much bugs in the millions of lines of code. I'm pretty scary. Anyway, it is very difficult to write complex software. And we need to fight against the complexity. The history of programming is the history of fighting against complexity. In general, small is beautiful. We can write small software. If we can write small software, it is more reliable, and it is more legit, it is more trustworthy. So small is beautiful. So what if one can write great software with less code? Isn't it great? So this is the whole purpose of programming productivity. Consciousness is my friend. Consciousness is the virtue of Ruby. I am a programmer, as you know. I wrote a software named Ruby. And I consider myself as a good programmer. So that I shared three virtues of great programmers, which are laziness, patience, and hubris. This is said by Larry Wall. So I am lazy. I'm a lazy programmer. So I want to code less since I'm lazy. So, and I'm impatient. So I want to finish early. So I want the result instantly, if possible. So I am hubris. So I can't stand to see bugs. So I can stand see bugs in my code, if possible. So we need a weapon to be productive. We need new tool. We need new way of developing or new language. Because programming language is so crucial in our life as a programmers, so we feel better using better programming language. So that better programming language, better life. So I created Ruby. It is concise and strip everything unnecessarily. For example, declaration, and static type systems. They are good. They are good things. With static typing system, we can find bugs easily without running code. But the type systems and declaration are not essential to the things we want computers to do. So I want to focus on the very essential of the task. That's the reason I designed Ruby as it is. So, and abstraction is the power to reduce code. So we want to hide a detail, so we don't want to see the detail. So remember the example of in the presentation of Professor Tanaka, which is it controls the robot. It only says that, okay, trace, left, right, trace, something. So we don't have to see about anything about the tracing algorithm or the controlling robot and the traction of the motors or something like that. So you don't have to worry about the voltage, and you don't have to about the controlling motors or something. So this is abstraction. So you can focus on things we want computers or robot to do. So that's the whole purpose of object-oriented programming. So you can hide out the detail in the object or class libraries, or functional programming, which can combine the task in the functional way, or meta-programming, so that the program itself can create the program inside, so that you don't have to worry about the inside detail of the, say, database access. Remember the active record. So active record generates methods inside to access the data in database, so that you don't have to worry about how to access the data record in the database. You just call database to fetch the record and access the record field. You don't have to worry about detail. By combining these features, object-oriented programming or functional programming or meta-programming, you can create a framework so that we can forget away in the detail of the programs or the computers or hardwares. And the most important things is the fighting leaky abstraction. So in the ideal world, you can easily forget about the detail. But we are living in the cruel real world. So sometimes the hidden hidden detail, abstract things leaks into the real world. For example, in for some programming language, especially name start with J, has many different types. It's there for performance, but they are not objects. So you cannot treat them as an object uniformly. So when you treat numbers, especially integers, so they are not objects. So you have to treat them as a value, or you have to wrap them into the integer class object. So this is a leaky abstraction. Or sometimes we have this integer size, 32-bit integer, 64-bit integers. So that means by 32-bit integers, you can handle the numbers, integer numbers, less than 2 billion something. So when you got the bigger numbers, it just overflows silently. So as a programmer, I sometimes use a silly example like factorial. So the factorial of 2 is 2, factorial of 6 is 72 or something. And but it's quite easy. The factorial numbers can easily be big, so you cannot calculate the factorial of 13, which overflows 2 billion. But in Ruby, the Ruby automatically converts the small numbers into the big numbers. So you don't have to worry about the overflow. So you can safely calculate the factorial for 200 set, for example, for whatever purpose. So this is the fighting against a leaky abstraction. So we care about the hiding, stopping leak in abstraction. So we made programming productive. So we helped programmers code less so that you can be effective, productive, so you can do great things. And then by using that kind of programming language, you can feel yourself as a great programmer. So you can satisfy yourself. You can be puffed up, and then you can be hubris, great programmer. So we help programmers become great, who is lazy, impatient, and hubris. Let's be one of them. Okay, this is the kind of strategy and the philosophy and the policy of Ruby design. Then we are going forward. So we are constantly improving Ruby in the past. So I started creating Ruby in '93. So this is 21st year of the Ruby development, 21 years. Thank you. And the community constantly improve Ruby to more concise and more fully abstracted. And then recent years, Ruby is getting better. So actually, Ruby is good enough. That's because we are here. That's because we choose Ruby, we program in Ruby, and the Ninefold choose Ruby. Because of Ruby is a great language, and we have Ruby on Rails and Sinatra, so you can easily build up the web applications or web API systems. And then actually, we can say that we have taken off the web. So as far as I've heard, so maybe more than 50% of the web startup in the Bay Area using Ruby. Probably that's true, maybe more. And then, so even though we have other programming language like PHP, Java, or Scala, Python, but we are very competitive in the web field. But no one complains about faster Ruby. So if Ruby gets faster, okay, why did you do that? No one said that. So we core team recently working on performance, especially the garbage collection, like this. Yeah, the we core team are kind of like a garbage collector. So the we citizens throw away the garbage and then forget about that. But these people collecting garbage and keep city clean, the we core team are kind of like that. So you write Ruby programs, and we core team implement and improve the core, the virtual machine, to make the city clean. And then we have to fight against C so that you don't have to write C. So you can happily live within Ruby. That's the job of core team. So recently, Ruby 2.1, which is the latest version, we added the generational garbage collector, which split up the object into two categories, two generations, and you know, by the fact most objects die young, so we create a new object in younger generation, then garbage collect on younger generations, scan of younger generation, then survived objects are promoted into older objects. So in old generations, most objects live long, maybe forever. So younger generations, the objects in younger generation die young. So by splitting generations, you can reduce the time spent in scanning objects. And then, so this reduces the time of the garbage collection significantly. So by our benchmark, the typical Ruby application become faster from 5% to 12%. But yesterday I've heard their test suite, which is kind of take hours to run. The performance time increased by half by just replacing 2.1. It is incredible. It's far more than we expected. Anyway, so we added generation garbage collection into 2.1. So we are going to release Ruby 2.2 in coming December. And then we are going to add 3 generation garbage collection, which means that we add a new generation in the middle of the old and young, which we call the youngest generation, young generation, and the old generation. So that means by 2 generations, so we sometimes promote young object mistakenly, just because an object was allocated just before the garbage collection. And soon after the garbage collection, the object died. Object dead. It became dead. But it's already promoted. So you have to wait until the next full scan, the scan of the old generation, until it was reclaimed. So the memory region occupied by this false old object is wasted for a long time. By adding the middle generation, so you can avoid that kind of problem. So we are going to add that. And in addition, we are going to add an incremental garbage collection to Ruby 2.2. Incremental means that the scan time, object scan times tend to be longer, just because we allocated the time of the object scan is proportional to the number of objects allocated since the last garbage collection. And then if you allocate a lot of objects, you have to scan a lot of these many objects. So the scan time tends to be longer when you allocate a lot of objects. But the incremental garbage collection split up the scanning into the fraction. So you scan the bit of the object, then return to the main main operation, then scan again, so that we can split up the time of the pause caused by the garbage collector. So the pause time itself is sometimes cause troubles. Like for example, if your application stopped 1 millisecond per garbage collection, no one noticed that. But once in 1,000, it stops for say 1 minute. So if your application, the one unfortunate user out of 1,000 access have to wait 1 minute to see the page, it is unacceptable for most of the case. So the pause time is very crucial for some type of the application, especially the real-time one. So if robot stopped 1 minute, probably it will fail. Or in games, so you control the shooting games, your machine stops for a minute, so you will die. So your player will get angry very easily. So the pause time is very crucial in some cases. So to address these cases, so we're going to add the incremental garbage collection. In addition, we are going to add a symbol garbage collection. And last year we had some kind of incident in Rails, Rails vulnerability. So the Rails has some kind of bug which generates symbols directly from user input. So by vulnerable input, so the one bad user can create a whole bunch of symbols inside of memory. And then right now, symbol tapes is not the subject of the garbage collection. So once the symbol is created, so it stays there forever. So the creating so many symbols inside will gradually consume up the memory, and it falls into the denial of service. So the Rails core team fixed that bug soon after the report, but we Ruby core team decided to address that so that we do not see that kind of problem ever again. We are going to add the performance things. We are going to add Ruby 2.2. So for the further future, we are going to address the JET compiler for that JVM and JavaScript do have. Or maybe we are going to implement a ahead of time compiler which converts Ruby program into the executable binary like RubyMotion does. So, but this is vague plan and idea, so we are not going to make promise about the time frame. By improving the language, we are trying to go beyond the web. Back in '93, when I started Ruby, no one used web, including me, myself. So the Ruby is not designed to be web programming language, unlike PHP. But nowadays, after Rails, everyone uses Ruby for web programming. So some young programmers consider Ruby as a web-specific programming language, but it's not. So we hope to go beyond the web. For example, we are going to go to the mobile scene, which RubyMotion is addressing that, and Ripon is addressing that, and we have another implementation of the mobile Ruby, the mobile Ruby, which is the mRuby embedded in the application framework, so that you can write iOS application in mRuby. Or maybe the field of scientific computing. In the university research, the Python is the strongest. Yeah, and MATLAB and all. So we admit that, but at least we want to provide the functionality to satisfy the scientific computing. So last year, the Ruby Association, the non-profit organization behind Ruby, has sponsored the project named SciRuby, which is the counterpart of the SciPy and NumPy. And we want to address the embedded field, like Professor Tanaka gave a presentation. So it means that embedded in devices like small computers or even robots. And then in addition, it also means that embedded in applications. So you can embed mRuby in games to configure, and or maybe in some application to provide the customization, like the Emacs embeds Emacs list to customize it. That's our mRuby, and then mRuby is a smaller implementation. So in syntax-wise, so mRuby is 1.9 compatible, fully compatible. But the library-wise, it's quite smaller, just because mRuby core is wholly written in C99. So requires C99 only. So if you can run mRuby on the platform everywhere that C99 is available. So it can run on, of course, Raspberry Pi or bigger board and a bigger Arduino. The first one is too small memory, but the recent one is bigger, so that's okay. And Professor Tanaka developed the stripped down version of the virtual machine, which only requires 16 kilo memory. And the unmodified mRuby requires, I don't know, maybe 50 kilo of memory, which compares to CRuby requires meg or memory. So last but not least is the embeddable API. CRuby provides the C API, by which you can enhance Ruby by C extensions. But mRuby, you can embed mRuby into your application. So the position is upside down. So you write application in C or C++, and you embed mRuby in it. But CRuby, by using CRuby, you have to write your application in Ruby, and then you can extend Ruby by C extensions. In the embedding field, you need that kind of the position that you embedded Ruby into your application, your system. Well, for example, we have something named mod mRuby, which is embed mRuby in Apache web server, so that you can control web server by writing Ruby programs. Unlike there's different things named mod Ruby, which purpose is to boost the performance of the Ruby programs, and Ruby programs like a CZI or something. But the purpose of mod mRuby is to control Apache, not provide dynamic functionality. For example, you can replace the mod rewrite by mod mRuby. but you can write the rewriting rule in Ruby so that you can understand more easily, since Ruby is the full programming language. Or you can throttle the access by using the interface to the C group functionality of Linux operating system. So mRuby is kind of like a Ruby that works like Lua, which is designed to be embedded. So in summary, Ruby next means Ruby that will be faster, and Ruby everywhere, and Ruby that keeps improving. So we are open source community. The open source community is kind of like a shark. We need to keep swimming. If we stop, we die. we have to keep moving. Since we are open source, we have no payment, so we are voluntarily gather together to keep doing interesting things. So that's our whole motivation. So if we stop progressing, so we are going to be less attractive. So the people has no mandatory, so people go away from Ruby. So it's no longer interesting. So go away to say Python, JavaScript, or Clojure, or anything like that. So you cannot stop that. You cannot force the community. So we have to keep moving. We have to keep being attractive. So I promise I will keep moving forward as long as I live, and I pass my inheritance to keep moving forward. So use Ruby, be productive, and happy hacking. Thank you.
You talked about the different garbage. You talked about the different garbage collection strategies.
Mm-hmm.
Do you get all of them, or do you get to choose which one you can?
We get all of them. A generational garbage collection, a generational incremental garbage collection.
Down the back.
Are CRuby and mRuby always they going to continue to be separate, or is there some idea of sharing?
Fundamentally, this mRuby has its own target, so it's not gonna replace CRuby. So mRuby for smaller devices and embedded in systems, and the CRuby for anything else. And probably you have the JRuby and Ruby, yes.
Any more? Next. In the front again.
Gil still there? Anything you're going to write, Gil?
We have big plan, but it's quite easy to remove GIL today.
Yeah.
But if we remove the GIL, probably more than 90% of your threading program will crash. And then they complain about that. So if we want to remove GIL, they complain about the existence of GIL. And if we remove that, they will complain about the crash. So we have no way. So we are choosing safer way. But we have big plan to add a higher abstraction of concurrency like actors. So after adding, so just because the writing correct threading program is pretty much difficult, nearly impossible. So by a higher abstraction like actors and CPS, so it is a little bit easier. So after adding that kind of abstraction, so we can remove GIL, so that we can blame them by using threads instead of actors. So when they complain about the crash, so use actors, not threads. So it's your fault to use these threads. But until that, then so we have to keep up here. Yes, Justine.
Yes. So we have some newbie programmers in the room, Ruby devs. source as a result of being a new Ruby dev, they want to contribute to the open source, right? What would you recommend that what projects do you recommend they contribute to?
You know, it's highly up to their motivation, the background, and anything. So whatever you want to interact. So keep say for example. So if you have anything in the open source project, probably in GitHub, so keep reacting, like submitting bug reports or send comments on it. Maybe if it's possible to send pull requests for any open source project. So you can contribute. You know, the voice of users is very valuable for open source authors, and then the pull request is more than valuable. So the contact and interact with the existing community and existing project. After that, you can create your own one. It's quite interesting. It's quite fascinating.
Question in the front, sir.
So I have a bunch of applications in Ruby, existing applications. Some of them rely on very important features of Ruby. One of them specifically, you're talking about implementing high-level abstractions of Ruby features in mRuby, and one of them specifically I'm wondering about is when are you going to implement flip-flop in mRuby?
Probably never.
Not ever.
So probably no one except you and me ever know about flip-flop exists in Ruby language.
What about?
Sounds like you might have to do it.
Yeah. No, thank you. Can you explain it?
Well, if you put the range operator ... in conditionals, like if something ... something, and then both sides the conditionals, it works like a flip-flop. Like it became true when the left hand is true, then it keeps being true until the next the right hand side conditional is true. But actually, I regret that.
Sounds like a long way. So
Yeah,
down the back.
I inherited it from Pearl.
Parsley.
This is kind of a continuation question, I guess. If you could go back in time and do any one thing different about Ruby, what would it be?
Remove thread and add active. Maybe we can simplify some corner cases like a scoping rules and something, and maybe we can remove some weird variables inherited from Perl, say $something, $colon, $comma, or something like that. But but these days these features are not encouraged to use. So yeah, I'm satisfied with current Ruby, with some spots and dots.
More questions? Yes, Professor
Oh,
Tanaka.
really? I have to be prepared.
You talk about the garbage question.
Yes.
Incremental garbage question is a good idea for real-time processing, or some kind of response is important area. That is a good idea. But you talk about also you talk about the Ruby also. In scientific area, the execution time is something longer, few hours, few days or more. So in such area, garbage question interruption is maybe overhead of the execution time. So is the garbage collection method is selectable, or so the configuration is available in Ruby 2.2?
Yeah, we are not decided yet, but maybe it can be configurable, so we can stop incremental garbage collection in compile time. But that's our simple measurement. So the cost of the incremental garbage collection is 1 to 5%.
Only 1%.
Yeah. compared to the whole garbage collection time.
Yeah, acceptable. Okay.
Yeah, maybe it is acceptable for most of the cases.
Thank you.
Oh, excuse me, I have a question.
Yes.
I'm just curious, how many hours a day via code, and how many days a week?
Varies. So recently I'm pretty busy about give a presentation and writing articles and communicating and discussion. So I spend most of the time doing that non-coding. But I set my rules to myself and code once a day for at least 6 days a week.
How many hours?
Depends. Maybe less than 15 minutes to 4 to 6 hours or something. But at least once.
Any last questions? Going, gone. Look, I think a big round of, there we are. Just
My question is, I think Node.js has kind of taken over some of the popularity in certain applications. Do you feel in the future is Ruby going to try to match the ability of Node.js, or it's trying to go different direction?
I'm not sure. I pretty wonder about why Node.js is getting so popular. Just because for Ruby, everyone complains about the jail, so that they want to use the multi-core. But Node.js, does not support multi-core at all. So it's a single-threaded model. But everyone loves Node.js, but I'm confusing. So the people love single-threaded model in JavaScript, and the people love multi-threaded model in Ruby. I don't know why. Yeah, but I want to see something comparable to Node.js in Ruby. We already have the event machine and cool IO, but its functionality is a little bit weaker. And since Ruby itself has a blocking IO, it is kind of dangerous to use Ruby in that purpose. Maybe we can use mRuby for that purpose, since the mRuby does not have any IO by default. So you can remove you don't have to worry about the blocking IO in mRuby. So by combining libuv, which is the back end of the Node.js, and mRuby, you can provide some kind of the similar functionality. So we already have the library to combine the mRuby and the libuv. So upon that, we can implement some kind of a framework to work just like the Node.js in Ruby. Yes, there.
So the Ruby culture, a lot of it seems to be a descendant of small talk development culture.
Yes.
When you developed Ruby, was that in your mind as well, or is that something separate that occurred culturally?
Yeah, I wasn't a Smalltalk user, but I read a lot about the Smalltalks, and I knew about Smalltalk, its class libraries and its language. So in the beginning of the design process of Ruby, I was pretty much influenced from the language like Lisp, which is the ancestor, kind of like ancestors of Smalltalk, and Smalltalk itself. So the influence you see in Ruby from Smalltalk is not a coincidence. It's intentional.